Now, before we do moments and talk, right, let's talk about what is center of gravity. Now, if I have a rod like this, okay, so do you agree there will be a lot of molecules here, millions and millions of molecules inside here? So each of them will have a weight, right? But if I were to total up everyone's weight, I will get the total weight of the object. Correct? So I will assume that the total weight of all the molecules, which is the total volume, total weight of this object, will be acting through a single point. So it's an assumption that it will act through a single point, which is called the center of gravity. So we total up all the weight and we assume the entire weight acts through a single point. So this center of gravity is just an assumed point. It's not really that only this point got the weight, because if you think about it, not only this point has the weight, because every part has molecules and each of them have weight, right? It's just that we assume the entire weight of the object is acting at a single point. So that is the definition of center of gravity. It is the point through which its whole weight is considered to act. So very important, you must have the word considered, because it's not really acting only to a single point. We don't assume that it's acting to a single point. Alright, regardless of the orientation of the body. So regardless of orientation of body means no matter which direction you rotate the object, the center of gravity will always be the same. A good example is in the case where you want to find the center of gravity of a non-uniform object. Okay, now when you were doing this experiment where you were given this piece of, let's say, oval shaped cardboard, and you were to ask to find where is the center of gravity, right now. So how would you know where is the center of gravity of this oval shaped cardboard? So what you would do is actually you would poke, use a needle or a pin to poke a hole and to suspend it, and then it will start to swing at first until it comes to rest, right now. When it comes to rest, we put a pendulum, hang it on the pin, which indicates a vertical line, because this is called a plumb line, which indicates a vertical line, because your pendulum will always be hanging vertically, right? So then what you do is you draw a line along here. That means your center of gravity must be somewhere along here. And then what you do, you can rotate the oval shape. Then let's say you hang this way, and then again you put the plumb line, and then you mark it. Right now, you draw a vertical line. That means your center of gravity must be along this line as well. So then what you do, since you already had the first line drawn from the first case, and now you got the second line, so the intersection will be your center of gravity. So no matter which direction you orientate the object, let's say you even try, let's say you put it like an angle like this, alright, and you hang your plumb line again, guaranteed the center of gravity will be along this line as well. And if you had marked the point earlier on, it will still be there as well. That means it will still pass through that point. That means all your directions that were passing through all will pass through your center of gravity. Because the center of gravity will never change. It will always be the same point regardless of the orientation of the body. Now, how does your plumb line enable you to get your center of gravity like what we did just now? Now, we will cover that later under moments, because we will learn later that the object, which is in this case the cardboard, right, the oval shaped cardboard, will always come to rest when the center of gravity is vertically below the pivot. So when it comes to rest, the center of gravity is vertically below the pivot. When it comes to rest, the center of gravity is vertically below the pivot. Why? You have to hold on. We will learn about it later. But in this part, we're just talking about it never changes position. Okay now? Okay? Now, some people ask me, is center of gravity the same as center of mass? The definition itself is not the same. Center of mass is defined as the point through which the whole mass of the object is considered to act. Whereas this is the point through which the whole weight of the object is considered to act. But in a uniform gravitational field, like on the Earth's surface, the center of mass will be the same as the center of gravity. They so happen to coincide. Do you understand? So it doesn't really matter for us. When will it be different? When you're talking about a non-uniform gravitational field. For example, in a non-uniform gravitational field, let's say this side let's say this side experiences more weight than this side, because here this side the gravitational field is stronger than this. So even though the center of mass may be exactly the center, but center of gravity will shift to the heavier side. So it depends on, but it's not in our syllabus. Okay, so for our syllabus it's always the same. Now then they also, you must know this, if it is a uniform object means it has a constant cross-sectional area, the density is constant throughout, then your center of gravity must always be at the geometrical center. So what is the geometrical center? That means half the length, half the thickness, and half of everything dimensions, linear dimension. It's exactly in the middle. That's what you're trying to say. If it's a non-uniform object, let's say this side is heavier, alright, and this side is lighter, then the center of gravity will shift towards the heavier or lighter side. Heavier side, your center of gravity will shift to this point. You understand? Okay, so all this is your basic.